Sometimes, instead of constructing a confidence interval after collecting data, we want to find how many people or observations we need before collecting the data. That's called finding the required sample size. The formula is n equals z of alpha half times sigma over e squared. In this formula, n is the sample size. Sigma is the population standard deviation. E is the margin of error. And z of alpha half is the critical z value based on the confidence level. Be careful here. This formula uses z, not t. That's because we are planning the sample size before collecting the data. One very important rule is that we always round the sample size up to the next whole number. Even if the decimal is small, we still round up because we need enough people or observations to meet the required margin of error. Before we use the sample formula, we need to know how to find the value z of alpha half. You can find this value using this table or using the TI-84 calculator. For example, a 90% confidence level has the critical value of 1.645. Now, I am going to show you how to find this number using a TI-84 calculator. Start by sketching a bell-shaped curve. Since the confidence level is 90%, we place 90% in the middle of the curve. So this area is 90% or 0.90. The total area under the curve is 100%. So the remaining area is 10%. So this piece is 5% and this piece is 5%. By the way, alpha is the remaining area. That means alpha equals 1 minus confidence level. So if I take 1 minus 0.90, I have 0.10. So alpha is the sum of this area and this area, which is 0.10. And this area is half of 0.10, so that's why we call it alpha half. And this area is also alpha half. This value on the horizontal line is negative z of alpha half, and this value is positive z of alpha half. The sample size formula uses the positive z of alpha half, which is on the right side. To find z of alpha half, we'll use the function inverse norm in the TI-84 calculator. And we need the left area, mean, and standard deviation. So this is where z of alpha half is. I want everything to the left of this number. So everything to the left includes the 90% and also the 5%. So the area to the left of this number is 95%. So the left area is 0.95. We are working with z. That means we're working with the standard normal distribution. And in a standard normal distribution, mean is always 0 and sigma is always 1. Now, let's enter this in our calculator. To open the distribution menu, we press second vars. Choose inverse norm and press enter. Depending on your calculator model, your screen may look a little different. Some newer TI-84 calculators allow you to choose whether the area to the left, center, or right to the z-score. If your calculator has these options, choose the option that matches the area given in the problem. Choose left if you're given the left area. Choose center if you're given the middle area. And choose right if you're given the right area. Feel free to use these options if your calculator has them. However, not every TI-84 includes these choices. To make sure everyone can follow along, I will always demonstrate using the left option. That means we will convert every problem to the left cumulative area before entering it into the calculator. So for this problem, I'll use the left area, and the area to the left is 95% or 0.95. We're working with the standard normal distribution, so mu is always 0, and standard deviation is always 1. And make sure the left option is highlighted. Then highlight paste and press enter. And then press enter again. This is our answer. This is what the calculator gives us. If we round it to 3 decimal places to match with the table, then we also get 1.645. So for a 90% confidence level, the critical value z of alpha half equals 1.645.